Welcome to the Blueprint of Invisible Forces, a comprehensive guide to electricity, magnetism, and engineering design. We'll explore the fundamental principles that govern the interaction between electric and magnetic fields. Tracing the origins of electromagnetism shows the separate development of electricity and magnetism until the 19th century convergence. Key figures like Ørsted, Faraday, and Maxwell unified these concepts, linking electricity, magnetism, and light. Electrostatics deals with the behavior of stalled charges, governed by Coulomb's law. This law defines the electrostatic force F, which is proportional to the product of two charges and inversely proportional to the square of the distance between them. Like charges repel, and opposite charges attract. Charges can be manipulated through conduction and induction. Charging by conduction involves physical contact and charge transfer. Charging by induction separates charges within a conductor without touching, often utilizing a ground connection. The mechanics of electricity in motion rely on three concepts: voltage, the electromotive force that pushes charges; current, the flow of charged particles; and resistance, the opposition to this flow. These are related by Ohm's law. Voltage equals current times resistance. Circuit architecture defines how components are connected. Series circuits have a single continuous path, while parallel circuits offer multiple branching pathways. These configurations impact current, voltage, and equivalent resistance calculations differently. Current typology includes direct current, a one-directional flow used in batteries, and alternating current, which reverses direction and is used globally for wall outlets. Diagnostic tools like the voltmeter and ammeter are used for measurement within circuits. A magnet creates a magnetic field, with magnetic flux lines moving from the North Pole to the South Pole. Magnetic field strength is measured in Tesla. At a micro level, magnetizing a material aligns its internal magnetic domains. Magnetic fields exert forces on moving charges. For a single particle, the force is calculated as QVB. For a current-carrying wire, the force is given by ILB sine theta, dependent on the current, length, field strength, and angle. Electromagnetism bridges forces by showing how electric current can generate a magnetic field, creating an electromagnet. This principle is applied in devices like a doorbell, where current through a coil pulls an iron rod to strike a bell. The three governing laws of electromagnetism are Ampere's law, where current creates a magnetic field; Faraday's law of induction, where changing magnetism creates voltage; and Lenz's law, which states that the universe resists change. Motors, generators, and transformers are cornerstones of electrical technology. Motors convert electrical to mechanical energy. Generators do the reverse. And transformers modulate AC voltage for safe and efficient power transmission. The engineering design process involves defining a problem, researching laws like Ohm's and Faraday's, brainstorming solutions, selecting the best design, prototyping, and iterating based on data, all within core constraints like cost and safety. Simulations help validate theory. Data analysis shows that induced current is directly proportional to both the number of wire loops and the rate of change in magnet speed. This perfectly validates Faraday's law of induction. The grand synthesis of electromagnetism powers the modern world, from energy generation via wind turbines to efficient transmission via transformers. Finally, it results in applications like fans within the home, utilizing motors and Ampere's law.